This video is going to continue Chapter 10, Triangle Trigonometry. We're going to continue looking at oblique triangles, and we're going to solve oblique triangles. So we're going to use the law of sines that was introduced in the last video, and we're going to specifically look at case 1. Case 1's great. If you're given where two angles and a side are known, then it makes your life a whole lot easier, because all you really need to do is find the third angle by subtracting, because you know that inside of here that this is 180 degrees. Inside, all these angles add up to 180 degrees. So if you're given two angles, then you can figure out what the third angle is, and then you're going to use the law of sines to be able to find the two missing sides. And you'll use the law of sines just two different times. Okay, and we've got some practice with that already. So let's go ahead then and look at this, and you can look at it and pause the video, try to solve it if you can. Okay, so let's see. One of the things that we can see that we're given is we can see that we have angle A is 47, and so that's right here. And angle B is 38, and that's right here. And we also have side A, which we know, which is 8 inches. Okay. My pen's being a little sensitive right now. Okay, so let's take a look at this and try to solve this problem then. We're going to go through our flow chart. Is it a right triangle? No, it's not. So we are not going to use any of the rules that we'd use for a right triangle, such as the Pythagorean theorem. And we're going to stay away from that. And so is it, so we're going to go, we know we're going to use the law of sines, and in looking at that, do we know a side and its opposite angle? Yep, we sure do. Matter of fact, we know two angles and a side, so we know that it's going to be case 1. And so, let's see, since we're going to be using the law of sines, we got them right here. Let's try to figure out, we're going to solve this triangle. We're going to put all the pieces together. So the first thing we need to do, the first thing we can do, there's multiple ways to skin this cat. And so first thing that I want to do, I want to start by figuring out what this missing angle C is. And so I'm going to go 180 degrees minus, that's a minus sign, minus 47 degrees minus 38 degrees. And so by doing that, I should be able to come up with C. So 180 degrees minus 47 degrees minus 38 degrees is 95 degrees. And so that tells me that this is 95 degrees. Okay, so now I have a degree measure for C. So now when I'm looking to be able to use my sine law of sines, then I'll be able to have that angle. So I was also given that A is 8 inches. So since I know sine A, or since I can find sine A, I'm going to write these out. I'm going to put it over A, and then I'm going to, since I know C, sine C, and I don't know what side C is, then I'll try to figure that out. So let's go ahead and fill in what we've got here. So sine A is sine of 47 over side A is 8 inches. And that's equal to sine C, which is sine of 95, over C. I don't know what that is, and so I'll leave that as a variable. And so let's go ahead then, and I'm going to show you a trick that works, and it hopefully will help you as you are working through these problems. If you have 1/2 equals 2/4 and you flip them both over and get the inverse for them, they still are the same. It's still the same answer. And so I can do the same thing for this. I'm going to take and flip this over, and so I'm going to put 8 inches on top and sine 47 on bottom. I'm going to put C on top and sine 95. Remember, it only works if you do it to both of them. Now what this does is it puts C, my variable, on the top as the numerator, so I don't have to worry about moving it around as the denominator. It's just a little bit easier and it's a little bit faster that way. So now I want to get C by itself though. So to be able to get C by itself, I'm going to multiply sine 95 times both sides. Let me get this off of here. Because what I do to one side, I have to do to the other. And so sine 95, let's go ahead and figure this out. And again, my calculator may look a little bit different than yours. And so, sine 95 times 8, that divided by sine of 47, and that equals 10.89, which I'm going to go ahead and round to. C is 11 inches. Okay, so let's go back and look and see how that looks in this problem. So that says C is 11 inches. All right, okay, so now we have that, and I still need to figure out B, so sine B. So since I already know sine A and I've been working with sine A, I'm just going to go ahead and just use it. And since I know I'm going to be putting my flipping these anyway, I'm just going to go ahead and put my value for B on top. So let's go ahead and rewrite this as A over sine A equals B over sine B. And so let's go ahead and fill in the values then. A is 8 over sine 47, which equals B, which we don't know, and over sine B, which is 38. And so we're going to get B by itself, isolate that variable. What we do to one side, we have to do to the other. And so get our calculator out. And we'll go make sure it's cleared. And .38 sine times 8 equals that divided by sine of 47, and that equals, so B equals 6.7 inches, and so that would make this 6.7 inches. All those numbers are fairly believable, and so I'm going to go with it that is the answer for this problem. One thing that you want to, again, make sure not to do is don't get tempted as you're moving through those problems and you start to get the sides that you can think you can use a Pythagorean theorem with oblique triangles. Remember, only with right triangles, and it's not the same as the inside measure of angles of a triangle. So make sure you keep those apart.